Hello everybody, welcome to the Santukaram National Model School, Latur. I am Varsha Shete. In today's session, we are going to discuss about the chemistry chapter Air and Oxygen for the class 7. In this chapter, in today's session, we are going to discuss about the hydrogen gas. As we know that the hydrogen gas is the lightest gas among all the elements present in the periodic table. As well as the hydrogen gas, its atomic number is 1 and it is exists in the molecular form, and that's why we are writing the formula for hydrogen is H2. Now, first of all, we are going to discuss about the properties of the hydrogen gas in the short. What are the physical properties? The first property is that it is the colorless and odorless gas, as well as it is insoluble in the water. As I told you that the hydrogen gas is the lightest among all the elements present in the periodic table. So that's why it is less denser than the air. Now go toward the chemical properties of the hydrogen gas. Whenever we are taking the test with the help of the blue litmus paper or the red litmus paper, it does not change its color. So this shows that the hydrogen gas is neutral in nature. And whenever we will burn this hydrogen gas, in the presence of air, it is burning with the pop sound. So that means we can say that the hydrogen gas is a flammable gas which can be burned. Okay, now go for the preparation of the hydrogen gas. In the today's session, we are going to discuss only about the two methods, how to prepare the hydrogen gas. First of all, we are going to discuss for the general methods, and that is nothing but the reaction of the water with the active metals. I'm saying that not all the metals, only the active metals. We know that the reactivity series, and in the reactivity series, at the top, the potassium and the sodium, these two metals are present because they are highly reactive. So here I'm showing you the reaction of these highly reactive metals with the water. As I told you that they are highly reactive or the most reactive, and that's why they can react with the cold water. Whenever they react with the cold water, there is a formation of their respective hydroxides as well as this hydrogen gas. Here I'm showing you that whenever these metals reacts with the water, there is a formation of their particular hydroxide as well as the hydrogen gas. Same thing is happening with the calcium also. Now go for the another method. As I told you that all the metals does not react with water in the same manner because of their reactivity. Now go for the magnesium, iron, aluminium, zinc. They are not so much reactive as like the potassium and sodium, and that's why they does not react with the hot water or the cold water. They can react with only the steam, and steam is nothing but the gaseous form of the water. So whenever this steam reacts with the magnesium, iron, or the zinc, there is a formation of their respective oxides instead of a hydroxide, and as well as the hydrogen gas. Here I am showing you the reaction of the magnesium with the steam as well as the reaction of hot iron with the steam. So there is a formation of their oxides, and as well as the hydrogen gas is produced. Now go for the second method for the preparation of the hydrogen gas. Generally, we are using this method in the laboratory for the preparation of the hydrogen gas. And what is this method? The reaction of the acids with the metal. We know that the different metal reacts with the acid, water, or the oxygen in the different method according to their reactivity. So same thing is happen here. Whenever the zinc is reacts with the hydrochloric acid or the sulfuric acid, so there is a formation of zinc chloride as well as the hydrogen gas. Same method here I am showing you for the preparation of hydrogen gas in the laboratory. Here I have taken the one round water flask, and this round water flask is attached with the thistle funnel as well as this bent glass tube. It is also called as a delivery tube. The thistle funnel or the lower end of the thistle funnel should be deep inside the acid. Now look at this. When I am adding the dilute hydrochloric acid inside this round water flask, automatically the zinc granule will start to react with the hydrochloric acid, and there is a formation of a hydrogen gas. As the hydrogen gas will form in this round water flask, it will pass through this bent tube and it will come here. Here I have done the downward displacement method arrangement. That means here I kept the cylinder in the inverted manner. Why? Because we know that the hydrogen gas is the lightest gas among the all. Here I am showing you the chemical reaction which is taking place inside the round water flask. Whenever the zinc reacts with hydrochloric acid, there is a formation of zinc chloride as well as the hydrogen gas. If the dilute hydrochloric acid is not available, you can go for the dilute sulfuric acid. And whenever the sulfuric acid reacts with the zinc, there is a formation of zinc sulfate and the hydrogen gas. Now, what is the last step? As I told you that the collection of the hydrogen gas is very, very important, and you have to go for the downward displacement of the water method because it is the lightest, and due to that we have to go for that. Now, one of the important thing is that is the which precaution we have to take during the preparation of the hydrogen gas in the laboratory. As I told you that the hydrogen gas is a flammable gas. It reacts with the oxygen and it catches the fire. So we have to remove all the air which is present in the cylinder, and then such type of the cylinder we can use for the collection of the hydrogen gas. So this is the most important thing for the during the preparation of the hydrogen gas. So this is about the preparation of the hydrogen gas in the laboratory. What are the chemical properties of the hydrogen gas and what are the uses of the hydrogen gas? We will continue in the next session. Thank you all of you. Have a nice day.